What we're going to be looking at is Pascal's triangle and how to use Pascal's triangle for binomial expansion. I'm going to start by filling in the coefficients for Pascal's triangle. So I always start with a 1, and then the next row has a 1 and a 1 in those boxes. And then the next row after that is going to have a 1 at both edges, but then in the center is going to be a 2. And then our next row will again have 1s on the edges, and then in the middle I'm going to have a 3 and a 3. Row 4 again has 1s on the ends, and then we'll fill in the center with a 4, a 6, and a 4. Row 5 has a 1 on each end, and then as I fill in the middle, see if you can figure out the pattern. There will be a 5 here, and then a 10, and then another 10, and then a 5. Row 6 will have a 1, and then a 6, and then a 15, a 20, 15 again, 6 again, and it always ends in a 1. Do you see what's going on with these coefficients? Let's go one more row. The first number is going to be a 1. Then the second value I get by adding the two values that are right on above it. So 1 and 6 puts a 7 in that box. 6 and 15, 21. 15 and 20, 35. 20 and 15, 35. 15 and 6, 21. 6 and 1, 7, and then always ending in a 1. You go ahead and try to fill out row 8, and I'll give you a few seconds. I know that was a lot of adding, so I'll go ahead and fill in 1, 8, 28, 56, 70, 56, 28, 8, and 1. Then we'll fill in our last row, 1, 9, 36, 84, 126, 126, 84, 36, 9, and 1. The next thing we're going to fill in is the variables a and b. Because we want to use this to expand a plus b raised to the 9th power, there's going to be a whole bunch of variables going on. So I'm going to start by filling in the a's. And you'll notice a pattern in the variables as well. This will start with a to the 9, then a to the 8, a to the 7, a to the 6, a to the 5, a to the 4th, a cubed, a squared, a, and then I'm out of a's, so this last term doesn't get an a. And then I'll fill in the b's, and the way that I like to do this is by starting at the right hand end with b to the 9th, b to the 8, b to the 7, b to the 6, b to the 5th, b to the 4th, b cubed, b squared, b, and then that first term doesn't have a b. In between each of these terms, I've left a space to put an addition sign. So that if I were to FOIL out a plus b to the 9th power, I would end up with this polynomial right there. Let's go ahead and fill in the next row up. Again, we look to this power to know what to start with, so this will start with a to the 8th, and then a 7th, a to the 6th, a to the 5th, a to the 4th, a cubed, a squared, a, and then in reverse order, b to the 8th, b to the 7th, b to the 6th, b to the 5th, b to the 4th, b to the third, b squared, b, and no b. And then addition signs in between. Why don't you try this 7th row, and while you're doing that, I'm going to fill in addition signs for the rest of my chart. Okay, how did that go? Let's go ahead and fill this in together then. I'll start with a to the 7th, a to the 6th, a to the 5th, a to the 4th, a to the 3rd, a squared, a, no a, and then reverse that, b to the 7th, b to the 6th, b to the 5th, b to the 4th, b cubed, b squared, b. And we'll continue like that for the whole rest of Pascal's triangle. In fact, you can fill in all of your first terms like this, all the way up the side. You'll notice that you always start with the power that you're raising your binomial to. So you'll notice when you get all the way to the top, a plus b to the 0, there's no a and there's no b. That's because if you remember, anything that's raised to the 0 power is equal to 1. So that's where that comes from. There are lots of patterns that exist in Pascal's triangle, and we'll talk briefly about some of them, but we won't get into very much detail. Right now, I just want us to fill in all of our variables so that we have a complete model to work with as we begin to see how to apply Pascal's triangle for expanding binomials. You want to make sure that you have a good working model before we start using this model, and I'm going to show you how to recreate it quickly so that you can use it instead of memorizing it. One thing I want you to notice is that always the outside edge has 1s for the coefficients, and then the exponents on the a and b match the power that is in that row. And each term, as you go through, if you look at the degree of each term, the degree of this term is 4, which is the exponent on a plus b. The degree of this term, we have 3 a's and 1 b, so this degree is 4 also. Here we have a squared and b squared, so the degree here is 4. ab cubed, the degree is 4. b to the 4, the degree is 4. So every time you have a term in a row, the degree for the monomial should match the degree that you are raising your binomial on the left to that power. Another quick pattern is we talked about this first outside row has all 1s. Well, this next diagonal goes 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's a difference of 1 between each term. And then this diagonal, there's a difference of 2 here, a difference of 3 here, a difference of 4 here, a difference of 5 here, 6 here, 7 here, 8 here. So there's lots and lots of patterns that go on in Pascal's triangle, and we will not be talking about all of them by any means, but I just wanted you to notice a few. Make sure that you have your entire chart filled out so that in our next segment we can use this triangle to expand binomials.